Oh, hello. 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 Are you there? Hello. Hello.
Hello, is it?
Okay. So
Hi.
network and its challenges. So we are looking at an image formed by an extended source. Okay. As I said, this is considered an extended source because it has a head shown by the arrow and then the tail. All right. This is just a point. So if you have this situation, how do you produce the image? Now, object distance is equal to image distance. So the distance from here to the object, F is 5, the same measurement. Okay. So automatically, once you take the same measurement, you have the position for the tail of the image. Please, are we okay? Are we okay?
No, please.
You see, by virtue of this fact that object distance is equal to image distance, if from here to here is 5 centimeters, then from here to here must also be 5 centimeters. So if I measure 5 centimeters from the mirror, I get the position of the tail, which is this end. Is that okay? That's what I'm saying.
Yes, please.
Good. Then, how do I determine the image of the head? Okay, a perpendicular line drawn from the object to the mirror goes undeviated. So once this is a perpendicular line, it will go undeviated. Now, because plane mirror forms virtual image, that is why I'm indicating the image at the other end with a broken line. Okay. Now, if I draw a ray hitting the mirror at an angle either than 90 degrees, so a ray of light hitting the mirror at an angle of 90, at an angle reflects to obey the second law of reflection. Now, if I extend this reflected ray, it has to meet the image at a point. That point would indicate where the head would be. So after retracing the path of the reflected ray at the other side of the mirror, where these two reflected rays meet would be the point where the image of the head would be. I can also draw another ray from the head hitting the image at an angle. It will reflect in this direction. When I retrace this path, it has to meet the other two reflected rays. But please, ray diagrams must be straight. So when you are doing it, you have to use straight edge. Where the two extended reflected rays meet will be the point where the head would be. So when I join it to the tail, it has to give me the image. And so this becomes the image of this extended objects with the tail and then the head. Please, are we fine?
Mr. Please, I have a question.
Ask your question.
Mr. Please, but can't you just measure the distance between the point O and the head? Then when you get to it, then you transfer the same thing. Since this side is also 5 centimeters.
You see,
or you have
that is easier. Yes, you can do that but you see, you have to explain it further using the ray diagram. How did you form? This is what you are saying. If this is 5 centimeter, 5 centimeter, the height is 5. Because let's say the height is 10 centimeter. Because I've located the tail, I just measure 10 centimeter and I'm there. When you do that, it's that easier way out. You have to explain further using the ray diagrams. Is that okay?
yes.
But the rule is that you don't litter the diagram with rays. At least 2 or 3 will do it. 2 or 3 will do. Let's go through the whole thing again. Let's go through the whole thing again for a better understanding. And as I said, please, when you are doing ray diagrams, you have to use straight edges or rule. So this is the mirror. This side to indicate the quoted end. I have an extended object over here. There's the tail, there's the head of the object. Now, object distance equals image distance. So if this is X centimeter, then I'm here. So automatically I have the tail. Now, what about the head? I know that a ray of light, which is perpendicular to the plane mirror, goes undeviated. So once this is perpendicular to it, it will go on and on and on and on. Yes, as Mirabel, as you asked, once I've located this line, okay, once I've located it, then it means when I extend this, I have the image. Is that not your question? Mirabel?
Yes.
But okay, but you have to use at least an additional ray diagram to explain this, not just one. So let's create another. The other ray diagram is that a ray coming from the object and hitting the mirror at an angle would certainly reflect to obey the second law. But when you extend the part of the reflected ray where it intersects the first ray, you see, I've used 2 rays, 1 and then 2, where the extended ray diagram for the second one where it meets this, the head must be there. Yes, I can end here. Once I have applied 2, I can end here. But I can equally apply another rule. Oh, okay. Or another ray. A ray coming from the object, hitting the mirror at an angle, would reflect at the same angle and will obey the second. Now, if I should extend this, where this also meets, you see, it's bending or it is deviating because I'm using free hand. That is why I advise that when you are doing this, you should use straight edge, okay? So when I extend this, where it meets the other ray or the other 2 rays, you have the image. So you don't just use the measurement, but use the ray diagrams to explain how the image will be formed. Please, is that okay? All right. Okay, let me send a shot. Now I'm giving you work. Your work is that I have the letter A in front of plane mirror. I have the letter A. I'll send a shot, please. So this is a plane mirror. I have the letter A. I want to draw an isometric A. Okay, let me draw a simple A. Now, and we see my time. I have the letter A in front of the mirror. Use ray diagrams, okay, to produce the image of this so that we will have a lateral inversion. I think the letter J rather would, because for A, the lateral inversion will be the same. If you have a J, I want to use an isometric J. Use a ray, just use a ray diagram to have a lateral inversion of this, to produce an image of this, which will be laterally inverted. Use a ray diagram. Please try it and let's see. Of course, it will turn so that this end would appear at this part of the mirror and the other side follows. Try and then use a ray diagram. Let's see how this will be formed. This lateral inversion can be formed. So just give it a try. Please, I hope you are trying. You are giving it a try. That's my version. That's my version of the lateral inversion. Okay. So let's see. Let's see what you can produce. Please, when you finish, send it to me. I want to see how you were able to create the lateral inversion of this gene. Okay. Now let's move on to formation of images in curved mirrors. Formation of images in curved mirrors. Formation of images in curved mirrors. We have two main kinds of curved mirrors. We have what we call concave one. We have concave. Oh shit, my marker today. Please let me change the marker and then it's a new marker. Give me a second, I'm coming. We have what we call concave mirror. This is concave or convergent mirror. Then two, we have convex mirror, or what we call as divergent mirror. What is a concave mirror? Or no, or how does a concave mirror looks? You see, a mirror is characterized by indicating where the reflecting surface is, and then the coated surface also is. So with a concave mirror, with a concave or convergent mirror, we have the reflecting surface curving in. The coated surface bulges out. So we have this end coated, and we have the reflecting surface curving in within. So as I said, the arrow always indicates the reflecting surface. So with a concave mirror, the reflecting surface curves inwardly.
Mr. J,
Hello.
the line is breaking.
I think it's It's a network problem. Please, is it better? Hello?
Yes.
Okay, so with a concave mirror, the reflecting surface curves in, whereas the coated or silvered surface is outward. So just as I indicated on the board, we have the reflecting surface curving in, whereas the coated surface curves outwardly. Then with convex mirror, with a convex mirror, convex or divergent mirror, it is the other way around. Here we have the reflecting surface curving in outwardly, and then the coated surface curving inwardly. So this is the coated surface or silver surface.
Please, can you take a picture time?
Okay, I'm coming. Whereas the arrow indicates the reflecting surface. Let me write the details and narrate, then I send you the. So here, the reflecting surface curves outwardly, whereas the coated surface curves inwardly. Okay, I'm sending a shot to the group. Please, I've sent it into the group. All right. So that is it with the curved mirrors, concave mirror or convergent mirror. Curves, the reflecting surface curves inwardly, whereas the coated surface curves outwardly. Then with convex or divergent mirror, the reflecting surface curves outwardly, whereas the coated surface curves inwardly. Please, are we okay? Are we fine?
Yes.
Let's talk about uses, the uses of the curved mirror. Uses of the curved mirrors. After discussing the uses of the curved mirrors, I'll ask you to, or I will expect you to put down some of the uses of plane mirror. Give me some of the uses of plane mirror. So let's first look at uses of the concave mirror. concave mirrors? Concave or convergent mirrors? Let's discuss. Can you tell me some of the uses of concave mirrors around? Perhaps you have, seen it used elsewhere, read something about it, or and all that. Can you share with me some of the uses of concave mirrors? Yes, the floor is open to any one of you. Yes. Do I have any? If you have any view to share, quickly do it. If you don't have it, then you let me know so we can continue. Hello. Yes, Mirabel.
They use it in headlights of cars.
Which one? Okay. Yes, it's true. The concave mirror is used in car headlight lamp.
No, wait, sorry. They use for
the car
shaving mirrors instead.
I'm coming. So we have the car headlights lamp. Okay. It is also used in okay, Irene, go ahead.
Please, they are used as a reflector in the headlights of cars and in search of light.
Search lights and then even touch lights. Yes, you are right. So it is used as a reflector in car headlight lamp, search lights, and
please, with the help of it, can the doctors use it to examine the throat, ears, nose?
No, that's a different technology. That's a different technology. Endoscopy. It's endoscopy uses fiber optics. It's a different technology. Yeah.
The dentist used to check the teeth. Is that one also endoscopy?
Oh, what you see, what the dentist use is a torchlight. But
that one,
a normal torchlight.
Torchlight designed for that purpose. Okay.
Okay.
So yes, it is used in car headlight lamps, searchlights, and then in torchlights. Okay. Do we have any more? Akofala, are you there? Senam, are you there? Abnaya, are you there? Give me your opinion. What do you think?
Yes, please.
So we've talked about headlights, lamps, torchlights, searchlights. And then, you see, the searchlight is what is used in the prisons. When you visit the prison, they have huge lamps, which is mounted on their walls. In the night, it is thrown around to search around the walls of the prison. Okay, hence the name searchlight. Okay, and then it is also.
Can we say?
Go ahead.
They are used in solar heaters to concentrate sun rays towards the food in the container.
Exactly, it's true. It's true. It's true. So used in solar heaters. To concentrate.
Please, what of shaving mirrors?
Yes. Yes, we have shaving mirrors too.
Okay.
It is also used in shaving mirrors. Okay, now let's talk about, we have quite a number of them. Please be reading around to add, okay,